To learn about all your projects too, so definitely chat with me. So I'm a professor. I'm a professor at a business school. I have a background in sort of a couple of different disciplines we'll talk about. I would say that most of my work studies conversations in some kind of form or another. And I know this is a very interdisciplinary group. Maybe are there any other business school type people here? None at all. Well, the good news is a lot of places like mine are hiring people like you. Certainly, you know, my background's in psychology, and then I studied a little economics at Chicago. So we're open to all kinds, especially computationally, right? Like, it used to be like a technology sector of business, and now every sector is a technology sector. So keep your mind open. I'm going to try and talk to you a little bit about the basic research we've done on a particular stream of inquiry, and then also maybe fold into how that actually turns from a research idea to a paper, to multiple papers, to open source software, to also teaching tools. Sort of full stack social science. And most of what, so like I said, most of what I do is I do a lot of natural language processing these days, and in particular I focus on conversational NLP. You know, I think conversations are fascinating, so my favorite part of every day is some kind of conversation or another, and every time you see people together, they are constantly talking to each other about all kinds of things, right? In the classroom, at work, you know, at home, out and about. I like to think of every relationships as our lives can be thought of as a series of conversations, right? So for all the people we know, think back to all the times we've talked to them, how we've learned about them in those conversations, the decisions we've made together, the decisions we've made when we're apart, right? And each of those conversations is sort of a transformational moment in the relationship as we strengthen the bond. Sometimes we tear the bond apart, right? Other times it goes in different directions. And I know there's some network people here. And I think we've learned a lot about the structure of social interaction from network analyses. But if you think about every one of these little bonds between people within a network, right? These edges, right? What is that actually, right? It's a series of conversations. These relationships are embedded, right? We think of these as sort of static pictures, but in real life, these are dynamic. They're building and unfolding over time, right? People get closer and further apart within the network. We form groups, and we have conversations within those groups. Sometimes the groups are defined by the contents of our conversation too, what we talk about. So I like to think about social interaction. I probably think about a lot of the same substantive questions that a lot of you do, but I like to think about it through the lens of conversation, because I think the technology for conversation has changed a lot recently, and has really opened up a dramatically impressive toolbox to allow us to answer these questions in new ways by thinking about them from the lens of a conversation. So when we think about conversations, right, we're getting data that kind of looks something like this, right? And this is even sort of a simplistic version of a conversation, right? So we have multiple turns by each speaker that are generated responsively over time, right? So we can't know what we're going to say here until we've listened to the rest, or maybe we've already decided what we're going to say no matter what the other person says, right? Which is sometimes even worse. And this is a pretty simple, right, here, so we're taking turns, right, there's a structure here where most of the time during conversation only one person's talking and everyone else is listening, right, and here there are nice little gaps, so we wait until the other person's finished and jump in, but the real conversation isn't nearly this structured, right, usually it looks a little more like this, right, people are overlapping, interrupting each other, people are misunderstanding one another, people are joining the conversation, leaving the conversation, right, so this messy unstructured data is more complicated than text analysis. I think even if we think about text analysis in terms of like a newspaper article or like a product review, what we call sort of a single voice document written from a single perspective, right? That's already complicated enough. There's so many words you could put into a news article. Every article is different, right? But then you take that and multiply it by all of the different people that could be part of a conversation and all of their goals, plus also this element of time as conversations unfold over time, right? What you say, the meaning of what is said depends on what has been said before. And so I think this sort of is almost like many dimensions of dimensionality that makes conversation a particularly messy and fraught but fascinating data set. And I think some of the problems that come up in conversation analysis are maybe similar to the problems you come up with when you're looking at mobile phone data or geospatial data or network data. Right? We're all trying to put a little bit of structure on a very unstructured world around us. So hopefully, even if you, I'm going to try and convince you today to do a little bit of conversation analysis in your own life. But even if I don't convince you of that, I think hopefully some of the same lessons will be useful. So I'm going to come back to this. This is a paper I recently had accepted. This is a review on all of the unique aspects of conversation analysis and why it's different from analyzing single author documents. There's great reviews of NLP for single author documents, newspaper articles, product reviews, legal statements, etc. No one's written a good review of why dialogue is different. And so we've done all of that. So this is the entire paper in a single figure. So every one of these boxes is a different section of the paper. And this is with a great team of people. Almost, I think Allison's the only one still at Harvard, but we all met at Harvard. And so I'll come back to this later. I'm going to talk a little bit about conversation. In the meantime, I want to kind of walk through, I think what the most useful thing for this session is to actually walk you through the workflow of how we built up our first NLP paper. So, I don't know how many other people in the room are psychology oriented. Okay, a few, great. More than business. That's great. JPSP is kind of a very old school psychology journal, and we had the second machine learning paper in the history of JPSP in 2017 on NLP. And there was the first paper I wrote with Allison Wood-Brooks, who's my incredible co-author here. So I'm going to walk you through the workflow of that paper because I think it highlights a lot of what's unique about conversation analysis and about applying tools to such messy data. But hopefully some of the lessons will be a little broader. So I'm going to come back to this, but let me work through the initial example first. So the paper we're going to talk about is about asking questions. We all ask lots of questions in our life. Hopefully, I would like you guys to ask questions whenever you want about whatever you want, by the way, too. Maybe that'll be easier. I'm used to more of a dialogue, especially when I teach MBA students. You can't get them to shut up, so please give me any questions. And maybe just to get started, let's just thinking about for asking questions, like why do we ask questions? Like, can we think of maybe quickly some costs and benefits of asking questions in a conversation? So don't all raise your hands up at once, but who wants to jump in? So yeah.
So yesterday we talked about advice networks and high status lawyers, and so someone with high status asking a question really loses some part of their status by asking advice.
Really?
Yeah.
Interesting.
Yeah.
So that's a cost, let's say.
Yeah.
There might be a cost to impression.
Yeah.
Right. People might think you're lower status. Any other costs or benefits? Can we get a benefit? Maybe, yeah, in the back.
Benefits is like getting knowledge.
Yes, absolutely. You ask a question, you get information back, hopefully. Or sometimes they don't answer the question at all, which is its own kind of information, right?
Yeah.
You learn about what they don't want to talk about. Any other costs or benefits we should think about here? Yeah.
Establish a relationship.
Tell me more about that.
Like start a conversation.
Absolutely, yeah. You ask a question, see where it goes, right? You build rapport. So I think this is good. And I don't know if anyone else has anything else to add. We got some really big categories here, like information and relationships are their own giant buckets, right? And we don't know what goes into that. But I think we got the ones that are important for me. So certainly when we ask questions, we learn information. We're used to that. I think we have an intuitive belief that this comes at some cost, right? There's some trade-off that we're pushing up against when we ask questions. And typically this falls under what I think psychologists or business school people would call impression management. We care about the impression we leave on other people. So, all of our behaviors affect our impression, and maybe our questions affect our impressions too. And typically psychologists break down impression management into two broad dimensions, right? Are you warm or are you confident? Do people think you're smart? Do people like you? Right? And I'm actually going to argue today that the answer to both of these questions, in general, is yes. That there are, in fact, no impression management costs. I'm eager to hear about this lawyer advice network example, because it's a perfect counterexample to the answer to the first part of this question. So, like I said, I'm going to introduce Allison Wood-Brooks, who's incredible. She has a book coming out next year. I'm going to see her in Boston in a week. We write so many papers together. She's one of the exciting reasons I'm still in this field. And so she had a great paper. Her job market paper was about this idea of if you ask people for advice, will they think you're smart? And there's an intuitive belief that we all have, I think, that when we ask for advice, people think we're less confident, right? Because we're demonstrating that we don't know the answer to something. But at least in a lot of the cases she's looked at, maybe people with relatively equal status, maybe in cases where there's one-on-one advice seeking rather than broad advice seeking, she finds that when we ask people for advice, they actually think we're smarter. And the reason is because we're so smart, we picked such a good advisor, right? It was them, right? So if I ask Nicolo for advice, he's going to think I'm smarter because I picked him. Right? You all might not think I'm smarter, but you're not going to think I'm any dumber, at least. Right? But I'm going to get that relational benefit because I'm seeking out an advisor I care about. And maybe I can seek advice from multiple people. But we show that actually people are wrong about this. They think that they're going to look dumber to the advice giver, but they actually look smarter. So there's no trade-off on competence. Let's talk about liking. And so that's the paper I'm going to introduce you to you today. It doesn't hurt to ask. Question asking increases liking. Now might also be a good point to mention that, so both of these papers do have Francesca Gino as a co-author. I don't know if anyone's heard the news. We are in the middle of a data audit. She didn't touch any of the data on any of these papers. Her situation is not involved with any of what we've done. It's very tragic. I could talk about it at length. I've been talking about it at length with many people. I think there's a lot of interesting questions about open science and ethics and transparency. All of our code and data have been on open science since we submitted, so this is as transparent as it gets. So I'm happy to talk about that offline, but let me just put that a pin in that now. Okay, so let me get into the actual paper, which is about whether question asking influences interpersonal liking. And so we collected in this paper first 2 lab studies where we had people have open-ended conversations. We did this over ChatPlat, which is itself a fascinating little computational social science tool. So Allison, with her research budget at Harvard, actually paid for this startup to develop a open chat platform. So you can, in a survey system, we can link people up online to talk to each other by typing. And she paid to make sure that the license was free so anybody can use it in perpetuity. So she's paying for the servers forever so that people can help to encourage more people to have conversation research. And so I think this is a really interesting part of how we make social science more computational. It's just making these tools more available. But in these studies, what we really wanted to do was run experiments where we would tell people in the conversation to ask more questions. And so in study 1, we had 199 dyads. And in these cases, one person was not given any instructions. We just said enjoy the chat. And the other person in each pair was either told to ask a lot of questions or ask very few questions. Study 2 is a very similar design, so we have 170 dyads. But here, we did sort of a 2-by-2 design where each person either got told to ask lots of questions or very few questions. And in both cases, our outcome is interpersonal liking. So we just have this measure. We have 4 Likert scales. They all correlate very highly with each other, and so we average them all together, and that's our outcome, right? So the question is, does our treatment, which is intent to treat measure, giving people instructions to ask more questions, does that lead to higher or lower liking? And the main result here is, in study 1, where we only gave instructions to one person, the person who was told to ask a lot of questions was liked more by their partner than the person who was told to ask fewer questions. And then in the 2-by-2 design, we show that no matter what your partner was told to do, whether your partner was told to ask lots of questions or few questions, that if you are told to ask many questions, you will be liked more than if you were told to ask fewer questions. So that's our main effect. Right, we've got a treatment, we've got a little bit of generalizability. We're done here, right? Great, okay. So you want more? Yeah, please, go ahead.
So here in the graphs, you put confidence intervals.
Yes.
So my question is, they're overlapping, no?
Yes, they are.
So it might, they might be there might be no difference.
So, a couple of things. So one is 95% confidence intervals, if they overlap, that they can still be significant. This is kind of like your eyes are maybe used to standard errors. This is also, we're also controlling for dyad effects, right? So we're doing a hierarchical model where we have dyad random effects. So these are actually these estimates are much more precise than the simple group means you believe. And we replicate this. It's shocking. These were run in 2015, which is even then pre-registration, but all the exclusion criteria are very clear. So I feel pretty good about the robustness of this result, but we have all that math in the paper. Any other questions before we get into the? Great. Okay, so we have a main effect. In psychology, we typically need more. We need a mechanism usually, and so we tried to find a mechanism. In this case, we thought this idea of responsiveness by Harry Rees was really powerful for us. This idea that when we're talking to people, we care whether they are listening to us, whether they understand us, whether they're validating what we care about and whether they care what we care about as well. And this is a measure of responsiveness. Now, typically, what we like to do is hand out surveys with answering a bunch of questions about responsiveness. We think that we had this hypothesis that, and this was sort of after, this was actually after our first submission. This was during the R&R, that the reason question asking makes you liked more is because you seem more responsive. So we got some annotations for this, but I think it's unsatisfying in a couple of ways. So let's kind of really drill down to our data. So here's a transcript here. Here's some people talking in our conversation. Right, so we have IDs, one row for every turn. We have user IDs, so these two people are talking together. There are timestamps at the beginning and the end of the turn. And so when people are talking, we can do two different types of annotation. And surely, so just quick show of hands, how many of you had like RAs do like annotation tasks for you? Okay, yeah, so a few more, yeah. It's a pretty common, we have some human intelligence. This is the way things were typically done, right? We don't used to have these tools, so we needed a person to walk through each row and label them. And a lot of the time, we'll get annotations that look something like this, where we have people reading an entire conversation and then evaluating holistically, right? How responsive is this conversation in general, right? And so here, there's lots and lots of features and cues you could pick up on in the transcript, but how those features map to responsiveness is not so clear. Even if we get a score, even if we get a significant difference. So here's the responsiveness scale. These are 18 items. This is pretty typical for like psychology or management scales. Maybe it's the same in other disciplines too, right? But it's like the outcome. So on a scale from 1 to 7, how much does somebody esteem you, shortcomings and all? So how much do they value your abilities and opinions? It's like, this is a really nice outcome. I can agree that this is something nice to have said about you. But like, what are the actual behaviors we want to use to be seen as more responsive, right? Is this really a mechanism or is this just another outcome? Right? Because, I can go into the classroom and try and teach MBAs, make sure that when you talk to somebody that they feel like you're getting the facts right about them. Like, how do they actually enact that? Are they going to enact it in the same way that the people in our experiments are? It's complicated. It's not very interpretable. You have this sort of black box idea of responsiveness, but some of these are obvious, like maybe listening is easier to enact, but I don't know how you enact being on the same wavelength. So that's sort of a pitfall of holistic approaches, right? Instead, I think what I want to show you is that by looking at from the behavior level, by annotating instead of at the entire level of the conversation, but at individual turns, we can learn a much more interpretable model of human behavior and get a lot of the same benefits for our analyses. So instead of thinking about how responsive they are as a whole, we can look at individual questions they're asking and say, what type of question is this? And maybe we had a hypothesis that it's not just the number of questions, but the type of questions that people are asking is really driving responsiveness. And I'll say one side benefit, so the interpretability is really good. I like the fact that it's sort of a very concrete, real life example. This feels like the real stuff of how we're talking to each other, right? The actual questions we're choosing to ask, the decisions we're making in conversation. That's certainly a benefit, but there's another side benefit, which is sample size. Right, so in our first two studies, we had 368 dyads, which is 736 people. So if we do evaluations of the entire conversation, right, we're dealing kind of small n, right? But within all those transcripts, there was almost 5,000 questions in the entire transcript. So by paying the RAs to go through and label the questions, we get many more observations, and now we can train a model with lots of extra sample size to understand what types of questions people are going to ask. So here are the types of questions that we labeled. So we did some pilot testing with some RAs, and we came up with a categorization, a typology of types of questions. And so every question in the study is put into one of these 6 buckets. So here are some examples. So there are follow-up questions where, so person 1 says they're going to Canada. Great idea. I'm from Canada. This is a Canadian accent, if you were wondering. And then this other person says, oh, cool, have you been there before? So they're asking a question that builds on what the previous person said. Then there's switch questions, so introducing a totally new topic, right? And then we weren't sure some people are kind of on the fence between follow-up and switch, so we had this sort of partial switch category. And then there's mirror questions, where the second person asks the exact same question to the person who just asked them, right? So you're mirroring it back. Then there's a handful of kind of obvious introductory questions, like how's it going, what's your name? And then there are rhetorical questions where you actually don't want an answer. The point is not to get an answer. So we had people label it. We had multiple RAs label each transcript for the question types. And so that means we get an alpha of reliability, right? So how often do the research assistants agree with each other? And in this case, you can see that they agreed with each other a lot. Yeah. They agree with each other a lot for introductory and mirror questions, right? So those are pretty consensus opinions on what makes a mirror an introductory question. Likewise, we get a lot of agreement on follow-up and switch questions, but we don't get much agreement on partial switch because it's kind of a halfway category anyway, right? And then rhetorical questions is harder than some of these. But also rhetorical questions are really rare, and partial switches are rare. So after we did the annotations, we said, okay, we feel pretty good at 4 of these categories. The other 2 are a little ambiguous, so we're just going to get rid of those 2 and only do these 4. And we're going to try and build a model to identify these 4 types of questions. In particular, we're going to care a lot about follow-up questions because these seem about responsiveness, right? This shows that I'm interested in what you're saying because I'm asking a question that I can only ask if I was listening to what you were saying before, right? Yeah, question?
So I feel like that mirror question is kind of like the follow-up question, isn't it?
It's similar in the sense, exactly. So we thought about this. So it's similar in the sense that it's on the same topic. But what I'm doing in a follow-up question is I'm asking you to build on what you just said before, right? Whereas in a mirror question, I'm almost asking you to build on what I just said, right? I'm asking you the same question you just asked me. So I'm not like having you add to the story, but I am staying on topic. And what's interesting, we actually have a paper in R&R right now where we look at topic preference. How do you signal your topic preferences in conversation? Like how do you tell somebody, oh, I like this conversation, I want to stay on this conversation topic, versus can we switch to anything else? Like I don't want to talk about football, you know, for example. So follow-up questions are a great way to signal interest in a topic, but mirror questions are not. Usually people ask mirror questions when they don't want to talk about the topic and they just want to get it off away, and they can't switch to a new topic. So they just let the other person talk for a while. But so mirror questions are not correlated with topic preference at all, but follow-up questions are very strongly correlated. So that's one instinctive, intuitive difference between the 2. Does that make sense?
Yeah, okay.
Great. Any other questions? Yeah.
Would you consider like some sort of like reverse questions where the person gives an opinion, like, don't you think that, and it's actually it's like rhetorical, but not really because it's asking for either agreement or disagreement?
Oh my God. Okay, so I have a different R&R on the idea of boomerasking. Actually, I just gave this talk 2 weeks ago in Greece. So a boomerask, if you ever met my dad before, you know what a boomerask is. So it's when they ask you a question and then they listen to your response, but then they just give their own answer to the same question, right? So like, how was your weekend? Because I had a great time in Torino, let me tell you about it, right? We know these boomerasks, and we find that boomerasking is actually worse than just bragging. And we look at positive, so ask brags are worse than just bragging. But also complaining is the same pattern. So if you ask somebody and then complain about the topic, it's worse than if you just gave them the complaint to begin with, right? And the reason is because it's this fake sincerity. It seems like I'm interested in what you have to say, but as soon as you answer, I just give my own answer, and you can tell that I wasn't really listening. So it's almost the opposite of a follow-up question, right? So that's a great, I love that you guys are already thinking of all of the other papers we've built on this. I should have presented something newer, but the boomerask doesn't have much NLP, so this has a lot of NLP, so I think for the method standpoint, this will be more interesting. I'm supposed to work on that R&R actually, so if you want to give some comments, I'm happy to share a draft. That'll be great. I'm going to talk with Allison about it in 2 weeks. This is awesome though. Yeah, question in the back?
So the unit labeled is the 2 sentences for.
So we're actually going to label. We're going to label this turn. The question turn is going to get a label. I'm giving you this first turn for context, but the actual label is going to go. We do this, for example, right? We're going to have another column that says question type, right? And each time there is a question in the row, we're going to get a question type label from the RAs. Switch, follow-up, mirror, etc. And we're going to have 3 RAs, and we're going to average them together, and when they disagree, they'll, right? But we're going to end up with a single column where each question turn has a single label of one of those 4 categories. Now, what you're maybe intuiting is, if I want to know what type of question this is on turn 10, maybe there's some information in turn 9 that's going to be useful for that prediction task, and I'll show you how we do that. But the label is still going to be on the row of the actual question turn. Anything else before we move on? I love all your questions. Let's keep it coming. I think you're all so smart, and I like you so much.
May I ask something?
Yes, yes.
The boomer question.
The boomer asking, yeah.
The boomer asking. The person who is responding to this so-called question
Yes.
can tell that this is not a question. And the person who is asking must be hierarchically upper in position to be able to use this method for a non-dialogue. It's not a dialogue when it's just an opening for the question. So in this case, register is playing a role. And did you account for that?
So I definitely agree that hierarchy and status are a big moderator here. So in particular, when we started presenting this, actually, we got a lot of feedback that it turns out in like the education world, boomer asking is like 50% of what teachers do, right? They'll ask a question, right? Like, you know, what city was the first capital of Italy, right? And then if nobody answers, then they'll jump in and they'll give the answer, right? Which I think
What's
is
the
Turin.
answer?
Yeah, okay, huh?
What, what?
I believe it's Turin, unless I did my research wrong. Yes, okay, excellent. Fabulous. I don't have a lot of answers on Italian history, but I have that one. Yeah, so teachers do that all the time. Maybe if you're a boss and you're trying to give a speech, you ask a rhetorical question and you answer it, right? I'm setting those situations aside. I'm saying in equal status positions, when we're just chatting, and it should feel natural that we're both learning about each other, but you're taking this as a chance to talk to me like you're a teacher and I'm a student. That's when the false sincerity really is annoying. We haven't run that study. I wonder. But there the status is, it's not just that the person is higher status, but the conversation is structured in a way that one person's a teacher and one person's a learner. Any other questions before we move on? I haven't even gotten to anything computational yet. But this is good, So you understand what's going on. So we have these examples. This is from, I think this is really fascinating. We'll come back to this. But conversation data is also really important because the trajectory of time across the conversations, these are all 15 minutes, I think is really interesting. And so here I'm just going to show you what percentage of turns in each minute bucket, this is sort of like a bin scatter, right? But there's time to it. So what percentage of turns in each bucket have these different types of questions? So obviously at the beginning you're going to get a lot of introductory questions like, hi, how are you, what's your name? But then it drops off instantly. And then, once we know each other's names, then we're going to bring in a lot of new topics, so full switch questions, right? And every time we bring in a new topic, there's a chance there's going to be a mirror question right after it, right? But these two tend to run in parallel, right? When we introduce a lot of new topics here, and we only kind of introduce new topics when we need to along the way, right? But here, over time, we see the slow rise of the follow-up question, right? So conversations don't start off with follow-up questions, but they are sustained by follow-up questions over time. And then we have our two weird categories, the partial switch and rhetorical. They're kind of just dribbling along in the bottom here, so we're going to throw those out. So we have 4 categories as an outcome. You probably see what's going to happen here, right? So I'm going to look at the text and try and build a model to label the categories automatically. And so when we think about how to label categories, we already have a couple of tools for how we do that. We've already had a few mentioned already this morning. So when we cluster documents, we often sort of think theoretically. We think, okay, well, is a single member model where each document belongs to a single cluster, right? Each turn is either a follow-up or a switch. It's not a mix of both, right? Or maybe you think about job descriptions, right? This is a job description for a teacher. This is a job description for a salesperson, etc. So very often we're stuck with unsupervised learning, right? Where we don't know the true labels. We think there are some categories, but we don't have the labels of what those categories are. And so we sort of project text into a feature space. We use this sort of geometric analogy where each feature count is a dimension, and then we can do some k-means clustering, right? So just to go really quickly through this, you guys have already gotten a bit of exposure to this already, so I'm going to zoom through this, but I'm happy to talk more about it. Right, so if you take these 3 documents and you count the features in each document, right, then you can think about like this dimension is the bad dimension, right? So document 1 is 2 in the bad dimension. Right, so you can actually think of it as a place in the space, right? Of course, there's many, many dimensions, right? Text is very high dimensional, but I'm showing you 2 dimensions. But once we get it into the space, then we can do the k-means clustering. We can say, okay, those two belong in a cluster together, and that one's on its own. Right, now with text, it's not usually spheres. K-means doesn't quite work so well. Very often documents are not a single topic, but a mixture of different topics. Right, and so what's most common, I think for any of you who've done a little bit of NLP with CSS, you've probably done something like topic models, right? Where you're assuming not that each document's a single topic, but a mixture of topics, right? And so you do this, they used to do a lot of latent semantic analysis, which is basically just principal components, but nowadays they do latent Dirichlet allocation, topic models. And the idea is here, you're relying on co-occurrence, right? Words that appear in the same documents together tend to come from similar topics, since you know a word by the company it keeps. Right, so you take a document like this and you say, okay, here are the biology words, the pink ones, the green ones are the neuroscience words, the yellow ones are the genetics, right? And so each document is sort of a mixture of these different topics. So I'm not going to get into all of this. This stuff is actually not especially useful in conversation data, but I'll show you why. But I want to introduce this because I think normally when we think about clustering, so here's an example from like consumer complaints. And normally when we think about clustering, we think about topic models, right? Time to uncover the structure, right? I want to use this in contrast though, because in our case, we don't have to discover the structure. We have the labels. The labels are categorical, right? But we still have the labels. We know for a fact that there are 4 types of questions in our categories, and each question is one and only one type of one and only one label. So now we have a supervised algorithm, right? We have our labels and we can train a model. Now, it's a little tricky because our outcome is not 1, 0, and it's not continuous. Our outcome is categorical. So we actually run a multinomial regression. So these are teaching slides, so this is from the R code. All the code for all this is up on OSF, and I'm happy to share slides, everything with you guys, by the way, but I'm just going high level now. So have any of you done multinomial regression before? Do you have exposure to this? Yeah. But the idea here is that the categories are the outcomes, right? And so, if a logistic regression is predicting whether something belongs to a 1 or 0 category, you can think about that as 2 categories, right? Then if we want to build a model for 4 categories, then we just train 3 logistic regressions, right? And then the 4th category is just the subtraction of the first 3, right? So for n categories, we just build n minus 1 logistic regression models, and the nice thing about the code is it figures this out all for you. So we put in some feature set, we have multinomial regression, and then for each of our categories, you get the probability that each document belongs to that category. So here's the output here. So we take a turn 1, right? We dump a bunch of features into the model, and then the model will tell us turn 1 has a 60% chance of being a switch question, high likelihood, right? Very unlikely to be introductory or mirror. It might be a follow-up, it might not be. And so we can make this deterministic. We can say, okay, pick whatever the highest category is. So turn 1 is definitely a switch question. Turn 2 is definitely a mirror question, and so on. Or we can do it probabilistically, and we can incorporate that uncertainty. So we can just treat these columns as predictors in a regression rather than extracting specific labels for every turn. Yeah, question?
Why would you use a regression instead of a classification model to try to fit into the type of question?
So it's multinomial, so our outcome is categorical, right?
Yeah.
So we need to be able to figure out the different categories. So you're thinking about like a classification tree or something like that?
To classify the type of question into the different classes, rather than using a regression model that gives you the inclusion.
So two things. One is we want to incorporate the uncertainty. So we don't want clear labels. We do want to have the probability of these things being, because like there's a difference between something being 90% likely to be a follow-up and 51% likely to be a follow-up. So we want to propagate that uncertainty down through the model. So when we put it into our final regression, we get that mixed into the recipe. The distinction, I'll say briefly, I'm happy to talk about this at length. The distinction between classification and regression is often more theoretical than meaningful in practice. So like a lot of the times when I predict binary outcomes, I'll use linear probability models and just like interpret the coefficients, and it's fine. I think people have a lot of a lot of statistical theorists have very strong opinions about the difference, but in practice they tend to be pretty similar. So that's my short answer to the question, but I can talk about that more later. Yeah.
I was wondering, these conversational large language models, do they follow this trend of conversation and turn taking, similar to human
Well, they're built based on turn taking, right? So ChatGPT won't give you a response until you talk back to them, right? Now, they're built on a particular type of conversation, which is question answering. So there's a lot of question answering data sets out there. And so the status differential in those conversations is very different than most of our human, right? It's basically a slave to serve our information needs. So it's very different in structure. But I will say, ChatGPT is built on this idea of next word prediction, right? Can we predict the next word from the previous words? Which is all just one giant multinomial regression, right? So if you think about the next word as a category label, right? And there's just like 100,000 possible words that could come next, right? So it's just trying to predict which of those 100,000 words is most likely to come next. And that's all just one giant multinomial. So for each word, it's just doing a multinomial regression over and over again. So I think the intuition is there. I don't have time to get into ChatGPT today, but I have thoughts. Let's get into some of the NLP, shall we? Okay, so we're extracting some features from the text. We're doing a bunch of stuff that you're probably familiar with bag of words, right? Where we're chopping up text into individual words and maybe some phrases, 1, 2, 3 word phrases, engrams. We're getting rid of rare words. We're stemming words, so that studied and studies and study and studying all get treated as the same count. This is all very standard text analysis stuff. One change we're making to this standard workflow is we're not getting rid of what are called stop words. So very often people will throw away stop words, which are the extremely common function words in English. And that makes sense when you're analyzing newspaper articles. Like, is this a newspaper article about the economy? Is it about the war in Ukraine? Is it about the BAFTA awards? Right? Is it about F1? That makes sense because these words don't tell you what the content is. But how people are talking, the structure of how they're talking, is almost entirely in the function words. And so in particular, if you think about our use case, where we're trying to identify different types of questions, if you'll notice on this stop word list, who, what, where, when, why, how, like these words are really important for figuring out what type of question it is, right? So we can't just throw this stuff away. So that's one big difference between conversational text and single author document analysis, which is that these function words matter a lot more because the style and the structure of how people talk is going to matter more. So we kept these features in. We kept all of these features in. You know, the pronouns, all of this stuff matters. So we keep it all in. And so we come up with a matrix that looks like this, right? So we have here our different questions, and we have our counts of the different engrams. But this actually, we thought we could do a little bit better. So here actually, well, before I do that, here are the examples of the types of engrams that tend to predict whether a question is a different type or not. And we kept question marks. That's treated as a single word within our algorithm. So that's part of the analysis. But you can see, so mirror questions are kind of a handful of phrases like how about you, what about yourself, right? And you. And then introductory questions are kind of obvious. Switch questions like new topics, like travel, what do you do for fun, where do you live, what are your hobbies, the weather, everyone's favorite topic. But then follow-up questions have, I think, also a very defined structure. So first you appreciate, like cool, nice, wow. And then you go deeper. So like, you know, where do you do that? How do I get into that? You know, what kind of painter are you? You know, why did you start doing that? So these are the engram features. We wanted more features though. Yeah, question?
Yeah, I was just thinking why you chose a bag word approach instead of like a kind of a word embedding style that takes a bit more context into consideration, like pre-trained embeddings.
That's a good question. So one answer to that is that this was 2015. Another one is, so the pre-trained embedding models, so I use those a lot, right? Like both word vectors, but then also sentence encoders too. They very often tend to get you a little bit more accuracy. That to me comes at the expense of interpretability, right? So even the fast text people will tell you we don't know what our dimensions are, and we can do interpretability exercises and look at parallelograms and try and figure out. You know, we can build locally interpretable models on top of these embeddings and give you a sense ex post of what the model's picking up on, but you don't actually figure out what the contents are, right? Whereas here, right, this is all very transparent and interpretable to computer scientists, right? All of our code's up on GitHub and OSF, but like my MBA students aren't going onto GitHub, I promise you, right? We need to have something more interpretable. So we actually want to extract the features directly and give them a recipe. So that's kind of the trade-off there. We have played around with word embeddings. The other thing is these are very short documents. So the word embeddings, in some ways, like because the question turns themselves are only like 20, 30 words long. So in some sense, the engrams are enough in that case. It's another advantage of studying conversation. We're not taking in reams and reams of text and trying to extract these broad themes. right? We're really focusing specifically on dialogue acts. So the embeddings actually don't help in this case, but there are lots of other cases where they do add a few % accuracy. Okay. We're going to add more features, and we're going to add contextual features. So not just features from the single turn itself, but other structural features that we think matter. And we added these because we did the model, and it worked pretty well with dagger words. We were getting about like 80% accuracy or so. But we could see some errors that we could identify. We built the model, we did the error analysis, so we looked at cases where the model was getting it wrong, where it was not capturing the RA label, and I was just inspecting what are the features of these turns where it's getting it wrong. What's the information that the model needs to get better at this? And a lot of the information we thought that was useful was in the other terms around the actual question turn. So for example, follow-up questions just tend to be a lot longer than other types of questions. So these are the coefficients from the lasso model we run. But there's other ones. So time into conversation, right? So meet your intro questions are very early, follow-up questions are late. So I showed you this plot before, right? So knowing what time the question was asked will inform you about what type of question it is. Also, mirror questions tend to be asked right after the other person asked a question. And they also tend to have an answer in the turn before they ask a question. So here's an example from our transcript, right? So if we're trying to label this question here, right, the fact that this person asked a question right before it suggests that this might be a mirror question. Also the fact that they gave an answer before they then asked the question, right? So that's information that's useful for distinguishing question types. And so in this case, we just extract features from these previous turns, and those become features of this turn. Likewise, there's also other features that indicate follow-up questions. So if the person who's asking the question has asked questions in previous turns as well, or if they're asking multiple questions in the turn, that's indicating that they're following up. So here, for example, this person, right, the fact that they asked a question 2 turns before is some evidence that this is also a mirror question because they're building on the same topic. Likewise, this person's actually really good at follow-up questions, right? So like follow-up question, double follow-up question, so 2 questions in the same turn, right? So this person's demonstrating a lot of interest in the topic.
I have a question.
Yes?
How do you code 2 questions in the same turn?
So we literally extract the feature.
Like, I thought the label would be per turn, and so what if someone asks a mirror question and then a follow-up question instead of the same kind of question in one turn?
Yeah, so in this case, so the label is actually not at the level of the question, it's at the level of the question turn.
Yeah.
So there were some isolated cases when people were asking a mirror question and also a switch question, or also an introductory. It wasn't common enough to make much of a difference. Those were cases, those were struggled. We struggled. Those were probably also ended up in the partial switch bucket. Yeah, there's always some junk in the data, but we had enough. Of the 4,500 question turns we actually had about 4,200 that actually went in the model. So we ditched about, that's like less than 10%, that's like 6% or something like that, that were a little too messy or the RAs couldn't agree. And that was enough. If we were dealing with 400 conversations, we couldn't ditch any of them, right? But because we have 4,500 of them, we could be a little picky about how we're training. So here's what we're doing, again. So we have these n-gram features, so every question has counts of different phrases, right? But then we're also adding these context features, right? So a property of question 2 is whether there were previous questions asked on the previous turns, right? So in the fancy NLP world these days, they talk about it as attention, right? So the detector for question 4 is paying attention to previous turns. And so we're building in those links by hand rather than having some giant neural network put like 100 million links and letting the algorithm sort it out. We're kind of in a small data set here, right? Which is, I think, honestly, most social science cases. And so we're using a little bit of domain knowledge to wire up the attention hard-coded. And that typically tends to be much more effective unless you're dealing with millions of data points than trying to let the neural network figure out what to pay attention to. So we have these context features, and this is our X space. So this is everything that's going into the right-hand side of our prediction model, right? The context features plus the n-gram features. And then we have these labels, so each question has a ground truth label from the annotators as a question type. And so when we put this in the model, this will all just be an lasso regression, right? Super simple estimation. And we're going to get an output here. So each question turn is going to be labeled as a percentage likelihood of follow-up, switch, introductory, or mirror. That make sense? Great. So here we have a confusion matrix, so we do a bunch of cross-validation here. We hold conversations out, and then we make a prediction model with all the other conversations, and we just iterate through that. So we have totally out-of-sample predictions. So we have our human labels on the columns and the machine labels on the rows. And so here's our confusion matrix. And so you can see every time the algorithm is accurate, there's an observation on the diagonal. So these guys here. And you can see we are 71% accurate at getting the exact label right, which is pretty good. Chance is around, if you guess the most common label, you get it right 35% of the time. If you guess random, you get it right 25% of the time. So 71's all right, but we care most about follow-up questions, and so we just think about distinguishing between follow-up versus the other types. Then we're at accuracy is about 87%, which is about as accurate as it agrees with humans as much as humans agree with each other. So we think we've distilled all the information we can get out of this, and we're going to move on, because this is as good as a new RA, new data. I'll also say the confusion matrix is really useful. I mentioned some of the error analysis we did before. I think the error analysis is really interesting here. Because you look at this, and the confusion matrix will actually tell you where the mistakes are being made. I don't know if any of you have gone through this workflow before. But for example, in this case, we thought our algorithm was pretty good, but there's room for improvement. So I don't know if you noticed, but the most common mistake that stands out relative to chance is this one over here. Right? So there just aren't that many mirror questions, but in particular, lots of them are being labeled wrong. And they're being labeled as switch questions. And the reason for that is, if you ask me, what city were you born in? And then I ask you, what city were you born in? That's definitely a mirror question. It's exactly the same question. But the problem is I'm not using the mirror question structure. I'm not saying how about you or what about yourself, right? So the literal text in the terms is the same. But the first one is a follow-up. The first one is a switch question, and the second one is a mirror question, right? And so those mirror questions where I'm asking you word for word the same question are being mislabeled here by the machine. And so I think if we were going to go back and do this, and I think I'm working on with a grad student on this to fix this up. But I think one thing I would want to do is to add a new context feature in my set, right? And say, what's the maximum similarity between this question and the previous 4 questions, right? Is there any question that was recently asked that is extremely similar to the question that you're the turn itself, right? And I think if we added that feature, then a lot of these would then be correctly categorized as mirror questions. Right, so this is how we're using the text. We're going back and forth between the text, but then putting our knowledge based on our reading into the algorithm. Right, and that iterative process is how we built this. Right, so we're not using the machine instead of reading. We're using it to actually make our reading more powerful. Anything else, or can I move on? Yeah.
Just to clarify, so something like that would use something like a semantic textual similarity between the previous questions and the threshold.
Yeah, I'd want to do a distribution of similarity. At what point is it actually kind of discontinuous, where there's some questions are extremely, I'd probably use some word embeddings to measure similarity, right? Yeah. We have sort of early stages of stuff like that, but that's the way to go, I think, there. But then all of that's just in the service of measuring, right? So we're doing the prediction, but then just to get the measure to then have that as a feature into the estimation of the model. It's not like we're investigating the theoretical boundary of what is or is not a mirror question. Right? Okay. We have one model. This works. We go through responsiveness. We have our mechanism. We do our bootstrapped effect. We can also do follow-up questions. I think follow-up questions are better. I think it's more concrete. I can teach this to people, and it also build a model. So with responsiveness, if you want to measure responsiveness in your data, you have to hire RAs and ask the same 12 questions we did. With this one, the algorithm's up there. You can run it in one line of code, and you can get it on all of your transcripts. And to demonstrate that workflow, so we wanted to scale up. I don't really like lab experiments myself. I like to work out in the field. So we wanted to put this in action. So for study 3 in the paper, we actually went to what I call a high-stakes impression management setting. So we had this data from speed dating. This is shared with us from Dan Jurafsky, a friend of ours at the Stanford NLP department. And I love this. They wrote a paper about this in 2009. It's amazing. It's a bunch of computer scientists sitting around talking about what is flirtation and how do we detect it in the natural world. It's like they're talking about insects, but it's students on speed dates. And so it is very heteronormative and very into the gender binary. So disclaimer there. But we have a lot of data of men and women on speed dates. And so If you've never done speed dates, it's 4-minute conversations. You talk to 20 people in a night. And then each one of them were wearing lapels with little microphones, so they recorded the whole transcription. And at the end of the conversation, they asked them, for all the people you met, person 1, person 2, person 3, would you want to go on a second date or not? And so that's our outcome, right? Can you leave a good impression based on the questions you ask? So, this is 85,000 turns, and now we have 19,000 questions. So now we have so many questions we probably can't even Harvard can't afford an RA to label all of the question types, so we need an algorithm solution. There's another element of this too. With this data is pretty sensitive, privacy concerns, right? So we got an IRB and everything. They were sort of very careful about sharing the data with us, but once they knew our intentions. But like in a lot of cases, you can't get human eyes on things, right? I do work with like the British government where we have like very sensitive text data, or like these guys did a project with like the Oakland Police Department where they were looking at the body cam footage, right? And you need a police background check to look at that data, right? But here's a case where instead of using humans, right, we get, if we already had this algorithm, we could have sent them the algorithm and they could have sent back the output, right? We could actually get around not just the size of the data set, but the sensitivity of the data set by using computational rather than human measures. So here in our data set, we're now just going to go do the exact exercise. We have a pre-trained model. We're going to go through the transcripts. We're going to find all the question terms and then label those question terms with our algorithm. So here you can see, in this conversation, the male asked a new question, and so this question, did you have anything fun? So this is a classic new topic question, right? We're switching topics. And then the female says, I went to Yosemite. The male says, nice, I love it there. You've been there. So this is a clear follow-up question. Yosemite is also very nice if you haven't been. Highly recommended. So they're getting along. He's demonstrating interest and validation. There's positivity and then a deeper step into the topic. And here, so our y-axis here is adjusted for gender effects because men just really want to go on second dates a lot more than women do. So there would be like two clouds at like 20 percentage points apart. But the slope is the same for men and women. So even adjusting for that gender fixed effect, both for men and for women, if you ask more follow-up questions, you will get more second dates. And so if you don't believe me, here's the regression. So here's our giant gender coefficient, right? And then only follow-up questions, but not the other type of questions, predict whether the person wants to give a second date or not. And that's true if we control for the total question count as well, other partner fixed effects, etc. A lot of stuff in the paper. So we have our model. We have the old school way of doing things, which is very holistic, human intelligence, but then we have this newer model, which is using human intelligence to actually power up the machine learning at scale. Yes?
We check for the order of the people meeting people, because maybe after the 5th people you're just tired and you're just going to be like, okay, no, I don't like this person. But if you were to be meeting with that person in the first round, then you could have been like, yes, I want to see this person again. Do you check for like...
That's interesting. So I wonder, we must have checked. I don't think it mattered enough to put in the paper. I would have guessed otherwise, like maybe you need a bit of a warm-up.
Okay.
Like settle into the night. I don't know. I could.
Maybe first 5 and then the last 5 you're just like, okay, no, I'm tired. This is the beginner. Then in the middle 10 you're just like, okay, you have the correct answers.
Yeah,
Like,
yeah.
that's my side.
So I will say, so the text is not posted publicly because that's sensitive, right? But the outcome data is all posted. So that's something we could look at, in an hour. We're not speed dating experts, right? We are trying to study. Yeah, it's a good idea though.
I have a question about that.
Yeah, please.
Were the ratings coming at the end of the night or after each date? People were rating whether they...
At the end, at the end they go through the checklist.
So it's even more like a memory effect, so the impression is even more memorable.
You get some recency,
Yeah.
maybe some primacy too though.
Exactly, both of the effects.
They give it like a little U, like a smiley face. All of these are great questions. I have answers to none of them. If you'd asked me in 2016, I'm sure I would have known. Yeah.
So, do you kind of get a measure of the first impression? Because maybe sometimes you just get by looking at the person, you can say, I want to go on a date with this person.
So they ran the experiment. They also asked questions like how attractive is the person, and then you can do not how attractive do I think you are, but how attractive does everyone else think you are to try and separate out some of those. You can look at, they asked how awkward was it, did you click, how funny was the person. They kind of really got into it. There's a lot of, I don't think they get enough credit for how powerful this data set is.
And were these questions asked right after they had the conversation or after accumulating 20 conversations and then remembering them and asking
I
them?
want to say it's at the end of the day. It's possible they had questionnaires with them. I don't know if they had time to fill in. They might have evaluated each date on like how funny, how courteous, how awkward after, but then the list of who do you date, I think that might have been at the end. I'd have to check again. Yeah. Does anyone have any questions about the text analysis? This is good. This is good. Yeah.
Like, how do you pair like all the dates? Cause like, are you like distribute like them like totally like randomized, or like just like putting people in pairs like according to their preferences, or like their background?
So not according to their preferences. So I think for each day they get like, 16 men and 16 women, and the women each sit at a table, and then the men. They will all sit down at one table, and then after the 4 minutes are up, they'll all just go to the next table. So everyone talks to everybody, which is kind of a nice part of the design. Yeah. Yes?
I wonder how to deal with the problem of reverse causality, because your outcome might have an impact on your predictor, right?
Yes.
Do you have any specific strategy for that?
And it's a tricky thing in conversations too, right? Because, so for example, the best predictor of whether someone succeeds in a negotiation is whether they say thank you. Right, but they're saying thank you because the outcome was good, not as an input. So that time part is tricky. We talk a lot about that in our review paper. I'll talk about that in a bit. In this case, the causality issue we deal with the experiment. Right? So we run the experiment where we randomly assign people to question asking instructors, and they give us a lot more follow-up questions. So that's, I don't like, I do write a lot of data papers with field data, but the combination of lab and field data I think compensate one another. And so I think in management there's a tendency, in economics as well, to write bigger papers that kind of deal with all of those problems at once, right? Rather than sort of smaller papers that kind of chip off little bits at a time. And so we think sort of the body of evidence as a whole. But you're right that if it was just the speed data, we would be worried. Anything else? Great. Okay, I'm going to get into this. Oh, so this is we don't have enough time today. This is my favorite part of the slide. So when I grab some stuff from it, so I teach this stuff to my MD. I teach text analysis and negotiations in my life. And I teach this paper in both of those classes. Emphasis on different parts at different times, right? But when I teach negotiations, question asking is such a fundamental part of how we get along with each other and make joint decisions, and we're really bad at it. We don't get a lot of practice. A lot of people come in and they think, they don't realize that you need to have a balance of being interesting and interested to get along with people, and so they really lean in on the interesting part, and so they tell all their best stories very quickly. They brag. They whinge, here's an interesting fact I learned on the news, or they kind of just wander through the conversation without being deliberate at all, right? So we try and practice listening, because when you listen to one another, you can find a lot more opportunity for win-win situations and negotiations. I won't go into it, but we do a lot of stuff on question asking, and I want to teach them the skills. And listening doesn't just happen at the turn level. So actually my co-author, Hannah Collins, does a great review paper. I should cite her here. But in this basic idea, which is when you're talking, I can do a lot of listening. So you guys are making great eye contact right now. I've seen some head nodding. Maybe you give little back channels like, yep. Right? But then once you're done talking, and it's my turn to speak, I can still demonstrate my listening. So I can affirm, right? I can say, oh, cool. I love that show. I can ask follow-up questions and have you build on the topic. I can acknowledge, especially in conflict conversations where there's a lot of tension, a lot of disagreement, saying like I understand what you're saying is important. And if you don't understand, you can also initiate a repair and say, can you explain? Can you tell me more about that? Right? Or is that an American thing, or you think it's for the world? You can paraphrase. There's all these tools you can do, and what's great about that is you're demonstrating listening while the other person is listening to you. So that's when they're most focused on whether they've been heard. And so you can demonstrate that listening when you're talking by doing all of this. But then you don't just have to do that on your next turn. You can actually demonstrate listening over longer time spans, right? So you can call back to previous topics. So something we mentioned before, like 20 minutes ago, shows I'm really paying attention if I bring that topic up again. Comedians will do this a lot in sitcoms, right? Because they're building this little world, this little shared reality. So the callback shows that the world is self-contained. You can also reflect and respond after the conversation is over, because every relationship is a series of conversation. And then before the next conversation, you can actually think about topics you want to talk about with your partner. We have a paper where we show that actually makes conversations better. It doesn't reduce the spontaneity. It shows that you've been thinking about the person when they're not around. And so by planning topics of conversation for people we know, we're actually building the relationship instead of making the conversation more forced and awkward. So we do this exercise in class after I teach them about the benefits of question asking. We actually go through this and we say, and I show them all the papers. So I show them the structure of the follow-up question. They understand how to do it, right? All that interpretable machine learning is coming to pay off. But then we actually practice this. So we're not going to do this. I don't have enough time today. But just in your mind, think about think about a tough question you might be asked, right? So maybe it's about your dissertations. Maybe it's about your living arrangements, maybe a romantic partner or a family member has some tough questions for you that you're not sure how to answer. But you can think about how this applies in a negotiation, certainly, right? People asking you, are you applying to any other jobs, right? Why do you really like this property, that kind of thing. So think about lots of different answers, and what we'll do is put people in groups of 3, and we'll assign them. So for 10 minutes, one person is the target, and the other 2 people are the journalists. And so the journalists will ask questions back and forth. And so the target is only allowed to give answers, but the question askers are only allowed to ask questions. And so asker 1 will go, and then asker 2 will go, and then 1 again, and then 2 again. And so you spend this entire time cultivating a mindset of curiosity and only thinking about follow-up questions you can ask the person, right? And so it's really good work. It's just practicing the skills of being a good journalist, right? And thinking about how to ask more questions. And I encourage you, when I was writing this paper, I would have conversations with people where I would have, honestly, 80% of the turns in a conversation are just follow-up questions, and they wouldn't notice because they love telling the stories about themselves, right? So maybe practice this. We have a social event today. Over the course of the rest of the week, as you all go home, and you can try this on people who don't already know the recipe. But you can learn a lot if you just focus on trying to ask questions rather than make statements. So it's good practice for the interviewers, but then also the target, the person being interviewed, is also really useful because then you get to practice the answering these tough questions. You can maybe answer it in different ways, right? If you want to dodge the question, if you want to avoid it entirely, if you want to say that you're not able to answer it, you want to say why, right? You can actually get experience rather than pretend making up, improvising the answer to a tough question in the moment, right? Negotiation success is a function of preparation. So we use these tools to make it easier for people to prepare for their tough conversations and make better choices when they're getting along with people they care about. And so there's a lot of feedback and stuff. Anyway, so we're sort of building this into the workflow, right? So we're not just Duncan Watts has this great quote, which is scientists tend to sort of accumulate knowledge and then throw it over the castle walls out into the rest of the world.